Hello friends, morning all of you. The teacher again, Dr. Shaukatali, standing before you to discuss a new topic. In the last class, we had a discussion on aromatic electrophilic substitution reactions. The reaction in which electrophile is substituted in an aromatic system, leading to the formation of electrophile substituted aromatic system. Aromatic system substituted with electrophile, you get finally, that is called your aromatic electrophilic substitution reaction. Further, we had a discussion on the general mechanism of aromatic electrophilic substitution reaction. Whether the reaction may be your nitration, sulfonation, acylation, alkylation, etc. Irrespective of what type of reaction, what the nature of the reaction is, each and every reaction is following three important steps. Number one, step number one, usually there is a formation of electrophile takes place, and in step number two, the electrophile substituting into your aromatic system by substituting the proton what we have in the aromatic system. One of the proton is substituted by an electrophile, and simultaneously, immediately after the substitution is over, there will be delocalization of pi electrons in your aromatic system, and as a result of which you get the carbonium ion gets revolved around your aromatic system. That gives stability to your aromatic system. And in the last step, the proton is getting removed, another proton is getting removed, and the electron what it left after removal of the proton goes into the aromatic system, forming full delocalization, full number of pi electrons as per your Huckel's rule. This is the thing we have discussed in our last class. Now we are going to discuss a new topic in continuation with your aromatic electrophilic substitution reaction. The first reaction what we are going to discuss now is nitration of benzene. Nitration. For this is a specific reaction in which you are going to substitute the electrophile NO2. NO2 plus is your electrophile in this particular reaction. This is the one going to substitute in your aromatic system, and finally you get nitrobenzene as your product. Nitrobenzene as your product. For this, what you need to do is you take benzene, required amount. To this, add required amount of a mixture of concentrated nitric acid and concentrated sulfuric acid. Take this in a RB flask in the laboratory. Fill this RB flask with your, after taking the content, just put a piece of your porcelain bit so that the pumping will not take place too much. Close this RB flask with a suitable lead condenser. Allow the water to circulate into the lead condenser. Start heating this over your water bath. Keep this entire setup over water bath and start heating. Once the temperature reaches around 60 degrees Celsius, maintain that 60 degree for at least 1 hour of time. In the meantime, the refluxation, that heating, the boiling of the mixture continuously takes place. This is called refluxation. That reflux, after 1 hour is over, you will get a beautiful yellow colored solution. You cool it, dismantle the entire center, cool the entire solution, allow it to cool down at room temperature for at least 1 to 2 hours. Then you pour the entire setup over your the filtering instrument, that is your Bunsen using your Buchner funnel. Keep a funnel and connect this funnel with your Buchner flask. Filter it using your suction pump. And while filtering, you will collect a beautiful yellow solid. Yellow solid, that's your nitrobenzene. That's your nitrobenzene, a beautiful yellow solid with maximum yield you will get once if you perform the entire operation strictly, the condition if you follow strictly. This is the simplest way of making your nitrated, that is nitrobenzene in the laboratory. Now we are going to discuss theoretically what are the reactions involved in nitrobenzene. I told you, I have explained everything regarding the laboratory method of making the nitrobenzene. Now the topic is that is nitration of benzene. For this, what you do is take benzene, add this with your nitric acid concentrated, and concentrated sulfuric acid also you take. Maintain 60 degrees Celsius. The product will be your nitrobenzene. This is the product, nitrobenzene. This is your ordinary benzene. This is your simple benzene. So benzene, when treated with a mixture of concentrated nitric acid and sulfuric acid at 60 degrees Celsius, around 1 hour of duration, you will get nitrobenzene, which is yellow in its color. The reaction in which the nitrobenzene is formed from benzene on treatment of this benzene with nitric acid and sulfuric acid concentrated mixture at 60 degrees Celsius is called your nitration of benzene, because you are substituting the NO2. This is the electrophile in this particular nitration. NO2 plus is your electrophile. Remember, NO2 plus is your electrophile in this particular reaction. NO2 plus, which is your electrophile, is getting substituted into your benzene, so that you will get nitrobenzene as product finally, which is yellow colored solid. Therefore, this reaction is called nitration of benzene. This is the simplest reaction. This is a simple reaction that explains how the benzene is converted into nitrobenzene. With this, we are not closing this discussion. Now we are going to discuss the mechanism behind the nitration of benzene. How, as I told you, there are 3 different steps involved, whether the reaction is nitration, sulfonation, etc. etc. That 3 different steps we are going to discuss now. You know that step number 1, formation of electrophile takes place. Step number 2, substitution of the electrophile into an aromatic system, followed by delocalization of pi electron takes place. And in step number 3, removal of the extra proton, so that finally the aromatic system, restoration of aromatic system is formed. As a result, the substituted product is formed, is your final step. These are the 3 different steps we are this session we have to discuss now. It is the right time to discuss the mechanism of nitration of benzene, in particular the nitration, simply called nitration. Since we are using benzene, this reaction is nitration of benzene. When you nitrate the benzene, the product is nitrobenzene. Remember, always remember, benzene treated with a mixture of concentrated nitric acid and concentrated sulfuric acid. Before this, you just write CONC. This particular CON represents concentrated. Again, here you write simply concentrated nitric acid and concentrated sulfuric acid at 60 degrees Celsius is the condition of this nitration reaction. This is your electrophile in nitration reaction. Right. Now we are going to the mechanism of your nitration. Step number 1, mechanism of nitration we are discussing now. Step number 1, as usual, formation of electrophile takes place. HNO3 plus 2 molecules of sulfuric acid you are taking gives you 2HSO4 minus plus NO2 plus H3O plus. As I told you, the electrophile is found in step number 1. NO2 plus is the electrophile. This is the one going to substitute in the aromatic system. Now step number 2. Benzene we have. Yes. NO2 plus is there in the medium. The temperature is right enough to carry out the nitration. This NO2 plus attacks this carbon atom, substituting the proton what we have here. One of the proton is getting substituted by your NO2. As a result, you will get this. Minus charge is created here, plus here, and because of this minus, NO2 connects and the remaining proton as such. After the substitution is over, the adjacent carbon from where the pi bonded electron moved to the next carbon, making this carbon negative. As a result, the NO2 plus getting connected with this acquire now the positive charge. And after this, you know very well that the delocalization of pi electron takes place by movement of this pi electron. This positive comes here, then this moves here. The positive from here moves here, and finally in the next step that we will discuss now. Step number 3. Step number 3 is simple. Plus is there, NO2 is here, hydrogen is here. Then we have HSO4 minus in the medium. This HSO4 minus will attract the proton, leaving the bonding electron. The CH bonded electron is left, and this moved inside, making this positive charge to cancel. That is, this cancels this positive charge. As a result, you will get the final product like this. Yes, NO2 plus H2SO. Nice. This is your nitrobenzene. Very clear, friends. This is very easy to remember. Remember, I told you that organic chemistry, as well as the reactions and mechanisms in organic chemistry is concerned, writing practice is very, very essential. Start writing, have the writing practice in your life, routine. You know that life. Have it, read it, memorize it. Start writing, goes on. Have this writing practice at least 100 times. The mechanism will reach you automatically. Whenever you want, you can recollect that mechanism. The entire concept of nitration of benzene, that is in particular the science subject, will come to you. If you want to recollect in the examination hall, that will automatically comes out. I repeat, the mechanism of nitration involves 3 different steps. Step number 1 is the formation of electrophile. Mixture of nitric acid and sulfuric acid. You are taking 1 molecule of nitric acid and 2 molecules of sulfuric acid. The temperature is 60 degrees Celsius. 2HSO4 minus plus NO2 plus H3O plus. And then step number 2, the electrophile NO2 plus is substituting this proton, leaving this proton as such. The temperature is 60 degrees, and this particular carbon acquires positive charge. And in the next step, this proton is getting removed by HSO4 minus, that is left over in the medium, and this bonding electron reaches here, making this cancelling this positive charge. As a result, you will get nitrobenzene as your final product. This is about your mechanism of nitrobenzene. See the board. Have a glance of the mechanism of nitrobenzene. It is very simple concept. Are you clear? Is it legible? If you have any comment regarding my voice quality, regarding the recording, defect, regarding your board appearance, you can write in my Google Classroom. I'll try to rectify the defect if I have anything. Right. Now, before I conclude the discussion on nitrobenzene, now we know what is nitration of benzene, how to carry out the nitration of benzene in the laboratory, what are the different steps involved in the mechanism of nitration of benzene, how to get the maximum yield in the laboratory. Everything we have finished discussion. Now the last step before I conclude, very important thing with respect to this I want to tell you now is, this is additional anyway for you. That step is your recrystallization of your nitrobenzene. We have prepared the nitrobenzene, which is yellow colored solid. How to go for its purification? Anyway, the yield what we get is maximum. After purification is over, you cannot expect the same amount of yield after the purification is over. Anyway, the little less amount you will get after purification is over. This is nature. How to carry out this refining? How to carry out this purification from crude to a pure one? That technique is called recrystallization technique. How to do this? Take a dried sample of your crude nitrobenzene in a test tube. To this, add enough amount of your ethanol. Try to dissolve this, shake this, test tube. Having a mixture of this nitrobenzene and ethanol, it will dissolve. Take at least 1 gram of your, no need to measure the nitrobenzene 1 gram exactly. Take a little bit extra amount of your nitrobenzene. To this, add at first half ml of, around half ml of, no need to, I repeat, no need to measure the ethanol, no need to measure your nitrobenzene. Take little ethanol, try to dissolve by shaking. If not, little heat it. Not much heating required, just warm it will dissolve. Add little more ethanol. Shake it will dissolve. Add little more ethanol. At one point, the nitrobenzene will not dissolve. It will remain as nitrobenzene. You can see this by having your, just by looking this test tube, you can see the nitrobenzene that remain undissolved. This state where even after adding the enough amount of ethanol, the nitrobenzene remain nitrobenzene. This particular stage is called the saturated stage. You stop it. Now, here this, simply show this test tube over your Bunsen, towards your Bunsen flame. Heating takes place. The entire thing will dissolve. See the test tube again, it will dissolve. You keep this in your test tube stand without disturbed for at least 2 hours of time. After 2 to 3 hours is over, simply take this and you can see now a beautiful needles of your yellow colored beautiful, the crystals of your nitrobenzene. You can see as a deposit over the surface of your boiling tube, or the surface of your this particular test tube. You scratch all these needles and put over the paper and see this again. You can see the beautiful crystals. This is your pure nitrobenzene. I repeat, this is your pure nitrobenzene. This is the recrystallized sample of your nitrobenzene. Yes, I hope you understand the entire thing whatever discussed in this classroom. With this, I finish my discussion. I conclude my discussion, and before I left this classroom, um, one thing, important thing, want to tell you is, as per the government, that mantra: stay home, stay safe, don't come out of your home to avoid the pandemic, spread of this COVID-19 virus. Thank you for watching my videos.